Hello everyone, this is our project Hybrid Robotic Lensman. So this is the structure of our robot. The framework of the robot is made up of a metal and then the framework is enclosed by plywood. So this is the side view of our robot and this is the front view. So this is the overall structure of our robot. So the main aim of our robot is to take photographs in social events. As the name suggests, hybrid robotic lensman, which means that this robot can be controlled in manual mode as well as autonomous mode. In manual mode, the user can control the robot using keys and move the camera according to his will and take the desired photographs he needs. So the another mode of our robot is autonomous mode. In this autonomous mode, the robot moves around on its own while the camera looks for people. When the camera detects the face, the robot automatically centers the face and then captures the image. After capturing this image, it again moves around looking for people. For detecting the face and then capturing it, we have used OpenCV libraries. And for the autonomous movement of the robot, we have used ultrasonic sensors. So this robot can be used in any social events for photography. Now we will talk about all the components that we have used in this project. Firstly, for the movement of the vehicle, we have used four 12-volt DC motors on all four wheels. Next, we have used two ultrasonic sensors for object avoidance, that is for the autonomous movement of the vehicle. Based on the output from the sensor, the robot makes decision for the movement. Next, we have used a linear actuator. It's a 12-volt linear actuator. It is used for adjusting the height of the camera. On top of the linear actuator, we have placed a pan tilt mechanism. This is used for moving the camera in 180 degree x-axis as well as 180 degree y-axis. This is helpful for us for taking an accurate photograph. Next is the camera. So the camera that we have used is a Raspberry Pi V2 version. It is an 8 megapixel camera. So these are all the major components of our robot. Other components in the robot is the main brain of our robot, that's the Raspberry Pi. We've used three motor drivers for controlling the motors, two for the DC motors and one is for the linear actuator control. To power up all the motors and drives, we have used a 12 volt 7 ampere hour lithium ion battery. So these are all the components present in our robot. Now let's talk about the working of our robot. So we'll look into the code by first booting up into the Raspberry Pi. So the first code is the manual control code. This is the code that we have written for the manual control of our robot. As we can see in the video, in the manual mode, the robot can be moved in any direction using the help of keys. And the movement of linear actuator can be controlled using the help of keys. It can be moved in upward direction and lower direction to adjust the height of the camera. Now we will see the working of our pan tilt camera. As we can see, the user can control the pan tilt mechanism, both the x-axis and the y-axis. The user has 180 degree freedom in both the axes. You can see in the video that the user is moving the camera in the x-axis. Here we can see the user moving the pan tilt mechanism in the y-axis. As we can see in the manual control, the user can see the camera output in his device. Here you can see the user moving the pan tilt mechanism to adjust so that his photograph is perfect as possible. Once the user is satisfied by the picture, he can manually capture it by clicking on the keys. Here you can see that the image has been captured. This is the captured image. The image will be stored in the location that you have designated to store the image in. So this is the program that we have written for the autonomous part of our robot. As we can see that in autonomous mode, the camera moves at 180-degree looking for a face. Until it finds a face, it keeps moving in 180-degree from left to right, right to left continuously. Here you can see that the servo motor is looking for a face. As soon as it detects a face, you can see that it says face found. The camera tries to fix the face to the center of the screen and captures the image. This is the image captured by the robot. The image will be stored in the designated location given by the user. For the movement part of the vehicle, we have used two ultrasonic sensors. We can see that the ultrasonic sensors sends back the output of the distance, and using this distance, the robot makes decision to move around, avoiding all the obstacles ahead of it. This is the logic that we have written for the decision making of the robot. When the distance is less than 30 centimeters ahead, the robot moves away from the obstacle. So this is the working of our robot. Thank you.